Welcome to room ENG225, which is used for EE316, Electrical Circuits and Electronics Design Laboratory. EE316 is required for electrical and computer engineering majors. The space dedicated to this laboratory is 830 square feet with a maximum of 12 students and one graduate teaching assistant. Students access the laboratory at the door entrance for ENG225. At this entrance, there are several signs, such as safety signs that inform students that eating and drinking are not allowed, the location of a first aid kit, and commonly used analog component information. General information about campus and laboratory emergency procedures is provided at the entrance of the lab. There is one emergency exit. Here is the lab's fire extinguisher. The Office of Environmental Health and Safety certifies the safety equipment on a regular basis. Note that the fire extinguisher was certified on July 2, 2021. Other resources at the entrance include an emergency action guidebook and a set of rules for expected computer use. The EE316 laboratory outcomes are for students to 1. Apply Kirchhoff's laws and linear algebra to analyze electronic circuits. 2. Employ circuit analysis, mathematics, and laboratory techniques to design, build, and analyze electronic circuits in the lab. 3. Write laboratory reports on electronic circuit experiments and designs to demonstrate proficient technical communication abilities. And 4. Gain experience using laboratory equipment to evaluate electrical and electronic circuits. This equipment includes oscilloscopes, signal generators, digital multimeters, and power supplies. It is our department's goal that this laboratory equips students with an ability to develop and conduct appropriate experimentation, analyze and interpret data, and use engineering judgment to draw conclusions in line with ABET Outcomes 3 and 6. Here we have the laboratory instruction space. The GTA presents laboratory concepts and information here using a 4-foot by 12-foot whiteboard and a projector. Students assemble among 12 workstations in view of this instruction space. Student workstations include a personal computer with internet connectivity and are used to view laboratory manuals, data sheets, schematics, and other information needed to carry out laboratory exercises. Each workstation includes the following laboratory equipment: an Agilent DSO 2002 oscilloscope with 2 channels, automatic triggering, 70 MHz of analog bandwidth, and 2 gigasamples per second sampling capabilities that allow students to take time domain measurements. Additionally, these oscilloscopes provide math functions like fast Fourier transforms that may be used to view frequency domain behaviors. This oscilloscope is used to characterize operational amplifier circuits, rectifier circuits, transistor amplifiers, and filters via the time series waveforms produced. A Gwenztek GPS 4303 DC power supply that allows students to power their experiments with voltages from 0 to 60 volts DC at currents from 0 to 6 amps with 0.01% load and line regulation. These supplies are digitally metered. They allow for voltage tracking and may be set as constant current or constant voltage sources. This supply has built-in safety features to protect against accidental overload and reverse polarity. A Gwenztek GFG 8219A function generator that is digitally metered and allows many waveform outputs at frequencies from 0.3 Hz to 3 MHz. This equipment allows students to measure the performance of amplifiers at specific frequencies. This function generator is used to characterize operational amplifier circuits, rectifier circuits, transistor amplifiers, and filters by serving as a variable frequency input source. 2 Keithley 2110 5.5-digit multimeters that allow students to make many high-accuracy electrical measurements including AC-DC voltages and currents, capacitance, resistance, frequency, and continuity. This multimeter is used to measure voltages in various resistor networks, output voltages of rectifier circuits, and transistor characteristic IV curves when paired with a Gwenztek GPS 4303 DC power supply. Additionally, each workstation contains ample power outlets, decade resistor boxes, and prototyping breadboards. EE316 allows students to construct several circuit designs and master the use of electronic measurement instrumentation. These labs emphasize electrical engineering concepts through a hands-on approach, allowing students to gain significant experience with electrical instruments such as function generators, digital multimeters, oscilloscopes, step-down transformers, power supplies, operational amplifiers, and various electronic components. Generally, each laboratory experiment involves a preliminary simulation of important background material via National Instruments Multisim software. These results are used for comparison to what should be analytically expected and then verified via a hands-on hardware approach using industry-standard electronic measurement equipment. Early lab experiments include Kirchhoff's laws for voltage and current, and Norton and Thevenin equivalent circuits. These basic concepts help acquaint students with simple measurements using digital multimeters. Students soon simulate, build, and test operational amplifier circuits such as inverting and non-inverting amplifiers, differentiators and integrators, bridge rectifiers, and AC-DC converters. For these experiments, students use oscilloscopes in addition to multimeters to make time-domain measurements that verify voltage gain, mathematical input-output relationships, and voltage conversion. In addition to several time-domain experiments, students also verify the frequency domain characteristics of various filter designs. Finally, students end the course by measuring the behavior of discrete transistor amplifiers as well as device characteristics of transistors, including BJTs, JFETs, and MOSFETs. Generally, preliminary assignments are completed prior to the lab period. Laboratory reports are due shortly after the lab period via online submission. Some assignments offer bonus points for advanced activities such as contrasting and comparing various transistor amplifier technologies. The lab course is concluded at the end of the semester with a final exam. Thank you for visiting ENG 225, where students earn an ability to develop and conduct experimentation, analyze and interpret data, and use engineering judgment to draw conclusions about analog electronics, all through analysis, simulation, and hands-on experimentation.